All right, welcome to this video where we're going to go through a concrete mix design. So this is going to be following ACIA 211 mix design procedure step by step. And so the first thing we need to know with any um, mix design operation is what goals or what objectives, what properties are we shooting for. In this mix, we want to have a compressive strength of 4,000 psi. We're going to make it air entrained at 6% air. So that's a little bit high, but that'll be okay. Then we are going to do our slump at 4 inches. And then we want to do a 20% replacement of the cement with fly ash. And this is by weight. So, and this is something a little bit different that we haven't done in any of our other examples. Then we have our aggregate properties. So we've done our aggregate lab and we've already measured these. All right, so first things first, we need our water to cement ratio, or water to cementitious ratio in this case. All right, so we had said that we were shooting for 4,000 psi, and so that, just following all the way across, we're going to use a water to cement ratio, or water to cementitious ratio of 0.48 because we are doing air entrained concrete. So 0.48 is our ratio. All right, so then we need to know what our course aggregate is, and I gave that to you in the problem statement, and so we said that it's going to have a 1.5 max and a 1-inch nominal max. Okay. Very important to note that these are different, and so we want to make sure that we keep these straight when we are going through and making our selections. So the first selection we need to do is approximate our mix design water. So we had said that we needed a 4-inch slump as a target. And so then what we're going to be looking at as our nominal maximum aggregate size. So I found my 1-inch column, and then I'm going to go down to the row corresponding to 4 inches of slump. Okay. So in this first one, note that it's for non-air entrained concrete, but we wanted to do air entrained concrete. So we're going to come down here and select 295. Okay. So we want this row for 295 pounds of water, and this is going to be per cubic yard of concrete. All right, so next up, now that we have our 295 pounds per cubic yard, now we can convert this into our cementitious content. And so this one's actually going to be 2 steps because first we need to find out our total cementitious, and then we're going to convert that over to the cement and the fly ash because we have 2 different cementitious materials that we're going to be using in this one. Now, what I'm going to do to make this a little bit easier on myself is I'm going to divide it by 27. Why 27? Because there are 27 cubic feet in a cubic yard. And that's going to give me a water content of 10.93. All right. 10.93 pounds per cubic foot. And then I'm going to look at my water to cement ratio, which we had already said was going to be 0.48, and I simply plug in what I have. So I have 10.93, and I have my cementitious content. Okay, now I'm going to flip that around, solve for my cementitious content, and I should get my total cementitious to be 22.76. And that's going to be pounds per cubic foot. All right, so that's total cementitious. Now, I had said I want 20% to be fly ash, so I'm going to put that here, which means that 80% of this is going to be my cement, or just my Portland cement. All right, and so when I break that up, I have 18 pounds, actually 18.21 pounds of cement, and the rest, 4.55 for my fly ash. All right, so now I have my water, and I have my cement, and I have my fly ash. So now we need to work on the aggregates a little bit. All right, so with my coarse aggregate estimate, I need the ACI table 10.8. Okay, so I'm going to use ACI table 10.8, where I'm going to have the fineness modulus of my fine aggregate, and I stated that earlier, and that's at 2.7. Now, I'm looking at the table. You can look this up later, but the table value here is a coarse aggregate fraction of 0.73. Okay, and I'm going to linearly interpolate the 2.7. On the table, it goes from 2.6 to 2.8, so you just linearly interpolate, and it's really straightforward to do it when I pick nice round numbers of 2.7. And so this is my coarse aggregate fraction. Okay, and when I have my coarse aggregate fraction, now I'm going to do use my dry rotted unit weight, which was, I stated this earlier in the earlier slide, of 10.6, and that's also pounds per cubic foot. I'm going to keep my units nice and consistent. And so I'm going to multiply that by 0.73, and I get a weight of my coarse aggregate to be 80.74 pounds per cubic foot of concrete. All right, so now I have my cement, my water, my fly ash, and my coarse aggregate. So all that really leaves us with is our admixtures and our fly ash. All right, so with our admixtures, we want 6% error. we can assume this 6% is going to be kind of broken up into about 2% entrapped, and 4% then has to be accomplished by chemicals. Specifically AEA, air entraining admixture. So what I'm going to do is this is where you have to look up the admixture dosage. And the admixture dosage is based on the cementitious content. And it usually is in fluid ounces per 100 weight or fluid ounces per 100 pounds of cement. So for this particular admixture, 1% of air, and this is the same one that we worked with in class, 1% of air is roughly 0.75 fluid ounces per 100 pounds of my cement. Okay. Now, when you look these up, you can find this information readily on the manufacturer's website. And it's a little bit challenging because this is not usually a nice clean number. This might be something like 0.5 to 3 fluid ounces per 100 weight. And that's because each cement reacts to the chemical a little bit differently. And so some cements, you might have to use a lot more air entraining admixture. Certain fly ashes are not conducive for being air entrained. And so all of a sudden then you will have to add a bunch of more air entrainer in order to accomplish the desired air entrainment level. So, and this is where the trial batches and testing comes into play. But for that, what we're going to do here is we're going to take our, we need 4% from the air entraining admixture. So I'm going to take 4%, and then I'm going to multiply it by that 0.75, and then I'm going to multiply it by the weight of the cementitious, which we had said was 22.76. That's pounds per cubic foot. Okay, and then I'm going to divide that by 100 pounds, okay, for the 100 weight. All right, and when I multiply all that together, I'm going to get my fluid ounces per cubic foot of concrete. Now, most of the time I don't have a measure that is going to be able to accurately measure fluid ounces. And so what I'm going to do is I'm going to add a conversion here that will convert it to milliliters, because oftentimes we have graduated cylinders in milliliters instead of fluid ounces. Okay. All right, and so when I multiply all of that together, I am left with 20.1, because it's milliliters, 20.2 milliliters per cubic foot of concrete. All right, so with certain chemical admixtures, you may need to consider their contribution of water to the overall mix. This is extremely important when you're going to very high strength concretes, where adding just small dosages of liquid in the form of a chemical admixture can actually significantly hurt your strength, and then you don't get the strength that you need out of your mix. In this case, we're not going to a very high strength, so we're just going to go ahead and neglect it for our volume calculations. Okay. Next up, now we can finally do our fine aggregate determination, right? And this is a challenging part. And so I'm going to write it through conceptually. Then I'll write it through with numbers, and we'll go from there. All right. So I'm going to start by saying I want some unit volume. My unit volume in this case is going to be 1 cubic foot. Okay. Now, what I'm going to do is I'm going to start subtracting out each of the known quantities, and basically any volume that's left over is going to be my fine aggregate. So first off, I'm going to go to my air. That's the easy one. Okay. And let's just write it out by words. Okay. So volume of air. Okay. So 6% in this case is going to be my volume of air. Then I'm going to subtract off the volume of the coarse aggregate. Then I'm going to subtract off the volume of my cement. Then I'm going to subtract off the volume of my fly ash. Okay. I'll write that out. All right, and then I also have water. Okay. And when I am done, I will be left with just the volume of my fine aggregate. So let's put some numbers to this. Okay, so I start with 1. 6% of that is going to be air, so 0.06. That one's pretty easy. All right, so now I have my volume of my coarse aggregate. This is where it gets a little bit tricky. We just dealt with a volume fraction of your coarse aggregate a couple steps ago. Do not use that volume fraction, otherwise you're going to get this to be a negative number, which doesn't make any sense. Instead, what we're going to do is we're going to use the weight that we had determined. Okay, so I'm going to put brackets around this. I'm going to use the weight, which was 80.74. And I need to convert that into a volume. And so I'm going to use the specific gravity. Of the coarse aggregate times the unit weight of water, keeping it in the pounds per cubic foot. All right, so I just need to make sure that my calculations, let's go back real quick, double check this stuff. Okay, 2.72 is our specific gravity of our coarse aggregate. Our fine aggregate is 2.15. All right, water is 1. And, oops. All right. All right, here we are. So our specific gravity here, I would plug in as 2.72, and unit weight of water is 62.4 pounds per cubic foot. All right, so now we can go ahead and we're going to subtract off the rest of those. to set this up like this. Okay. All right, so that's the volume of my coarse aggregate. Now we need the volume of my cement. I'd said that that's 18.21. Specific gravity of cement is 3.15. Okay, now I'm going to do the volume of my fly ash. I had that at 4.55 pounds. Fly ash is at 2.2 specific gravity. Okay. Volume of water, I am using 10.93. Specific gravity is 1. And the unit weight is 62.4. Okay, so this is my coarse aggregate. This is my cement. This is my fly ash. And this is my water. All right, so I do that math and I come up with some volume of my some volume for my fine aggregate, okay? And that comes out to actually 0.16, and that's in cubic feet fine aggregate. All right, so then I'm going to use the same principles that I did up here, only now I need the weight and I have the volume. So what I'm going to do is I'm going to do 0.16 feet per cubic yard times the specific gravity times the 62.4, and this is going to be 2.15. And that gives me a weight of 21.92 pounds per cubic foot of concrete that I'm mixing. All right, so now I have each weight of the constituents. So here is where I can go ahead and start making my moisture correction. Okay, so my moisture correction is to adjust the mixture to compensate for the aggregate being too wet or too dry. In this case, I made the aggregate too dry. So the fine aggregate I said was minus 1.1%. So it is under SSD. And for the coarse aggregate, it is minus 0.5%. Also under SSD conditions. All right, so to correct for that, I'm going to simply take the weight that I calculated previously. So if I'm going to do my fine aggregate first, I'm going to start with the weight that I just calculated, 21.92 pounds per cubic foot. Okay, and then I'm going to do 1 plus the moisture content, okay, which in this case is going to be negative, so it's going to be minus 0.011, and that's going to be the corrected fine aggregate quantity. And that corrected fine aggregate quantity is going to be 21.68. Then I'm going to do the same thing with my coarse aggregate. Only here we have a lot more of it, so it's going to be 80.74. And then times 1 minus 0.005. And that's going to give me a value of 80.33. All right. Now we need to do our water correction. And to do my water correction, I basically just have to figure out how much I adjusted the aggregate. So in both cases, I went down in the amount of aggregate in terms of weight. Okay, and to think this through, okay, so my aggregate is dry. This value represents that aggregate being at perfect 100% SSD. Okay, so it's all the pores are saturated, but the surface is dry. Okay, that's what this value represents. But because I'm not at that state, the surface is dry, some of the pores are dry, I'm actually going to put in a smaller weight of aggregate in order to get that same volume of aggregate. So that way my mix stays consistent from a volume standpoint. So what I'm going to do here is I'm going to simply take my water and I'm going to just take the difference of my original SSD fine aggregate to the corrected aggregate. And so I'm going to do 21.92 minus 21.68, and that's going to give me 0.24 pounds. And then doing the same thing over here, we do 80.74 minus 80.33, and that is 0.41 pounds. Okay, so those are my differences in the terms of weight of my aggregate. And so what I'm going to do now, okay, now I think in the original example I had these numbers flipped, okay, and then it was the original water minus each of those numbers, okay. But because I know what's going on, okay, these are both water added. Okay. Now, if you follow my original example, because if you invert those and you go to the equation where it's like water original minus the difference in the aggregate weights, you'll get the same value. I just know that for this, I was keeping the numbers positive. I know for both of these, this is the amount of water I have to add to the mix. Okay, so I'm going to do that original water, which is 10.93. And then I'm going to add each of these, so 0.24 and 0.41. And this is going to give me 11.57 pounds per cubic foot. Okay? And both of these are both in pounds per cubic foot still. So everything's in pounds per cubic foot, everything's nice and consistent. I have my corrected values. These are the values that I'm going to go ahead and head into the lab, start mixing, because the next step is your trial batch, where you are going to batch it out according to your design, and then you can make adjustments based from that particular um, from that particular batch. Okay. Now, let's say, for the sake of argument, sake of going through this, let's say that our strength was okay. So strength was fine. Let's say the slump it wasn't 4 inches like we wanted. It ended up being 6 inches. And air, that was okay. So all we'd have to do here is to change our slump. And what we had said that in the lecture, if we want to adjust our slump, it's going to be 1 inch of slump is roughly equivalent to 10 pounds per cubic yard of concrete. All right. Now, in this mixture, we had started with 295 pounds per cubic yard. Okay. Now, it's important that you keep these units consistent. Okay, and this I actually do all of this in a spreadsheet. That's why you see me continuing to look at my other monitor here, because all these numbers are already in a spreadsheet. With that, if I overshot by 2 inches, what I'm going to do then is I'm going to bring this down to 275 pounds per cubic yard. Okay? So my original mix, I'm going to just list this out. Okay, we had cement, we had fly ash, we had fine aggregate, and we had coarse aggregate. Okay, and um, we really had an original mix where the cement was 18.21, the fly ash was 4.55, the coarse aggregate was 80.74. Oops. I don't know what I did there. Okay, 80.74. And our fine aggregate was 21.92. And finally, our water was 10.93. Okay. Now, this was the SSD. Okay. And then we go to actual conditions. And that changed our cement. Not at all. All it did was change our aggregate, which our coarse aggregate went to 80.33. Our fine aggregate went to 21.68. And our water went to 11.57. Okay. And so that's what got us this result. And so what we would do then is now we would actually go back all the way to step. Okay. We would adjust this value that we found in step 4, which was 295, and we would pick it up in step 5. Okay. And so then the correction, and I'm just going to stay on this one instead of going to the next one, just for simplicity. So with this one, now we're going to, with the, and again going off the same row, our cement now is going to go to 16.97. Our fly ash is 4.24. Our coarse aggregate is still 80.74. Our fine aggregate now is 24.66. And our water is 10.19. Okay? All right, now we will do the same set of corrections as we did with the previous one. So this is now going to, well, it's still going to be 16.97. This is still going to be 4.24. Okay. Our coarse aggregate goes to 80.33. Our fine aggregate now is 24.39. And our water ends up being at 10.86. This is our actual mix then. All right, so that's how you adjust off of it. Okay, now if your air is off, that will there were recommendations in the lecture how to adjust if your air is off. If your strength is off, you have to adjust the water to cementitious ratio. But what they've done with this this whole procedure is to really try to isolate certain parameters to tie them directly to outcomes. And so for workability, it's this water content. For strength, it's water to cement ratio, and air. Well, that really comes down to the chemical dosages that you have to work with. And so in this example, we develop this mix, and then we correct it off of that. Okay. If you have any questions, please let me know. Otherwise, good luck with wrapping this up with your CLRs.